All right, Mopar people, welcome back to the channel. I'm just Mopar Joe, and this is Brian Salter from Salter Racing Engines. We have a 538 big block Mopar camshaft shootout that Brian is kind enough to be involved in. I got three major respected names on YouTube and in the racing world, engine world, Brian Salter, Daniel Powell, and David Vizard, the great David Vizard. And all three are interested and willing to participate in our cam shootout. So the idea is get the engine on the dyno, swap cams on the dyno, get our results, and try to find a winner. It's still up in the air. How do we judge this thing? But I've got some good ideas on how I want to. And I talked to the dyno guy there, Aaron, at Combustion Company in Arkadelphia, and he said, "Man, you're going to have ultimately, you got to make the choice." So, if everybody weighs in, there could be more than one winner, but in the end, we have to pick one. So I think it's going to be exciting results. Can I give a quick rundown of our build, Brian? Do you mind that?
No, go right ahead.
Okay, so it's a 538. This is in a 440 big block Mopar. That's the tall deck for people. It started as a 440. Anyway, 4.5 inch stroke, 436 bore, 7/100 rod. And I was going to ask you some questions about that stuff later. And this is going in a drag and drive car. So the man has I believe it's a 73 CUDA. He's going to TKX swap it, or I'm going to TKX swap it, let me say. I believe we got a 373 gear and a 295/65 drag radial. It's a really tall tire. He sent those to me the other day. So I've been stacking parts above my engine room. And he's got, 2 feet of parts here so far. So I'm gathering it all up. Anyway, I guess my first question for you, if you're ready.
Sure.
What do you think? What do you think about our engine situation? Having that 4.5 inch stroke and the smaller bore. So, is it going to give us a challenge? The man wants to spin at 6,500 RPM.
So the challenge is with any type of stroke that large is, can you feed it? Mm-hmm. And I think y'all, outside of spending an enormous amount of money on exotic stuff, 10, 11, 12 degree or 9 degree head, stuff like that, because the hood issue comes into play as well. Want to be able to shut the hood, not have really tall intakes and things like that. So you stayed with pretty much what we call the factory valve angle. And at the time, you correct me if I'm wrong, the Trick Flow 270 head was pretty much one of the best out there as far as on factory bolt-on type of deal.
Yeah.
And it would CNC ported, and then you send it to Charles Servillo, and he went through and did what he could with it. So the stroke is your issue as far as RPMs, but the good thing is in this situation, 6,500 RPMs is easily accomplished. It's not asking too much, I don't think. You're going to have some other issues that crop up that we'll talk about.
Mm-hmm.
But in reference to your question, what do I think about it? I think to me, 6,500 is considered low RPM.
Right.
And I think you're right there. I think you're taking advantage of the parts you have. You're maxing them out. I think you'll be just fine.
Okay.
Are there better suited applications? Yes. Is there better heads? Yes. But you have to take in consideration what the goal is, trying to stay with a stock hood, also not trying to spend $1 million,
right.
Run pump gas, drag and drive it. Mm-hmm. So I think it should be very well.
Yeah. And I meant to say earlier, like, I think our goal is 11.5 to 1 compression. So that was coming up in a minute. I know you have some good stuff on that recently, even. But my second question, let me stay in order so I don't lose track. What do you think about the rod to stroke ratio? I know a lot of, especially racing teams, they always consider this, and they have big arguments about the longest rod possible or shortest rod possible. Ours is 7/100 rod, 4.5-inch stroke, so it's 1.57 to 1.
Yes. Yeah. So I've done a couple videos on this. Like, I think it's like some of my very first videos because, I've been making videos on YouTube, about 17 months, 18 months.
Mm-hmm.
But that is always one of the hottest topics. And what I found, and along with several other major businesses, if you will, Rear Morrison, people like that, is we look at compression height. I look at deck height. Correct me on this if I'm wrong here again, but that 440 is a 10.725 deck, right? Or roughly?
I think that's right.
Okay. So that's your limit, right? You've got a lot of crank in it, a lot of crank.
Mm-hmm.
So you start stuffing in a lot of rod. Now you've got a really short compression height on the piston. If people don't know what that is, compression height is from the center of the wrist pin to the top of the piston. And I have a number that I try to stay within, which is about 1.150 inches. I don't try to go below that because you lose too much stability, and any gains from a rod is now thrown out the window because your piston's rocking all over the place.
Mm-hmm.
So I crunched a couple numbers. It looks like you're going to be around 1.375 on the compression height with the 7/100 rod, and that's with the factory deck, because you may have cut the deck more. So let's say it was the original deck height of 10.725 with the 7/100 rod. Subtract half the stroke, you're looking at a difference of 1 inch, 375 thousandths. That's the most compression height you could possibly get in that block with that rod. Now, that's taller than my bare minimum, right? But let's just say you took it to the absolute longest rod you could, which would be about 7.325. That's the longest rod you could put in it with that crank. I mean, at least under my 1.15.
Right.
You're only looking at a couple horsepower gain, maybe 3, and that gain would be at the bottom. I can guarantee you this would be the lower half of the RPM scale. Your gain would be not at the top, regardless of what people think, and you would wear this thing out, because here's the thing that people don't understand. With this really long crank, you're going to have tremendous rod angularity. And I mean tremendous rod angularity. This is one thing I do like about Dodge is their deck heights are much taller than any other big three, on average. So like your 454 block is an averaging around 9,800. I know they make a 10.2. The big block 460 is around 10.3, 20, somewhere in there. And so the Dodge really shines on the deck height. So it's more conducive to bigger strokes and longer rods. So with that being said, the rod angularity on a 4.5-inch stroke is a mile. It's a lot. It's a lot, which means you're side loading in certain positions, not in all the positions, just in certain positions. Well, if I'm side loading because of extra stroke length, and now I've taken my piston skirt and top from here to here, that really applies a lot of pressure, and it just basically shortens the life of the engine. That's really what it does. It shortens the life of your piston and ring combination. So the power you may make on the dyno won't be the power you're making 6 months from now, provided you're driving it all the time. So that's the key, is you want to be able to maintain the same power you came off the dyno with. You want to maintain that power months and even years down the road. So finding that balance is the key. As far as the rod ratio goes, I think where you're at, I think it's 1.57. When I do my endurance motors or the open wheel NASCAR motors, we've gone as high as 1.8. But you have to understand, we're turning 85, 8,800 RPMs. I have seen 9,000 qualifying, and we rebuild those often.
Right.
And I can tell you from just a season, and when I say a season, let's just say 1,500 laps. 1,500 laps, that piston is you can tell that the skirt is this big.
Right.
Because even with a 250 or 300 stroke, the rod angularity is nowhere near as severe as a 4.5 inch stroke. With the skirt being that tiny, it just really wears on that skirt. It starts rolling the bottom of your skirt. What you'll do is start rolling the edges, and once you start rolling it, then it just really is rocking. Start rocking, you lose your ring seal. That's when your numbers start to fall. So, and
Right.
the first sign of that is pan vacuum goes down and all kinds of other issues that show up. So, I think these big strokes are getting more and more popular. They're more and more available. We're building rods now that are made to clear cams for big strokes, whereas used to we had to modify everything. So the rods are now coming into play where they're easier to use. The oil pan selection is out there way more than it used to be. We're able to balance these things way better than we used to be. Piston availability. I mean, my gosh, I used to spend 2 or 3 days on pistons in the shop, and now you can call up Molly or whoever and buy them with all
Right.
the bells and whistles done. So the public now has such great access to the best parts, whereas we used to have to make everything. Don't get me wrong, you can still get a custom piston that's better than what you buy off the shelf, but I'll tell you, off the shelf stuff has gotten really good.
Yeah.
As far as the rod ratio, I think you've done the right thing. I don't think you pushed it too far because you could go another 2.25 and squeeze it out, but I think you would suffer longevity wise by doing that, and you're not going to gain anything worth talking about. So I'm liking what you did there personally. So yeah,
Well,
I think it's the goodest choices you could have made.
yeah, I try to. So that was the owner of this engine wanted that, for his drag and drive, and I kept trying to talk him down. Let's do a 500, 512. Let's do a 470. Shorten
Yeah,
that stroke up. Get a longer skirt on the piston, longevity. Nope, he wants the big stuff. So that's, I think, as big as we can stuff in a factory block. And
yeah,
he did previously had well, long story short, he had a nice aftermarket block and it went away out of his control. So he's now kind of settling for this stock block, and he had me find a better block. It's like the late 70s 440 that has a certain thicker main web to it. So it is a little stronger than the average block, but
yeah.
we're going to
I'll
push
tell
it
you,
and see.
I personally now I am a fan of square or over square type situations because I like to turn the RPMs. That's just a preference. But let's say that he had stayed with either a 3.750 stroke or even 4 inch. Um, with these heads, the capability to make more power was there with the shorter stroke for sure. But
Right.
you're going to trade that 6,500 for now 7,000.
Mm-hmm.
Or you're going to really, let's just say you will maximize that 65 to 6,800. Whereas the way it is now, is it going to peak at 59 at 6? We won't know this till we check it on the dyno, but you're going to take way more. Let's just say his mid to upper RPM range would be a whole lot better with a shorter stroke. But if he's going to drag and drive it and not really try and kill the thing, I mean, there's nothing wrong with cubic inches. And he may decide later on to get a way better head, and then it's just a top end swap. And
Yeah,
because the
that's
bottom
true.
end is there. So, there's just pros and cons, and however you look at it. And really, how much money do you want to spend?
Yeah, I agree with that.
I do
So that was
recommend the light ring package, though. I will say that.
what's that?
With a board this big, this is your issue. With a board this big, you got now a lot of surface area where that ring is pushing against the cylinder wall. And the stiffer that ring is with that larger bore, the more impact it's going to have on parasitic drag. So which it's already done, it's a done deal. You're going with this stroke, you're going with this rod, you're going with this diameter piston. I think you've told me you're waiting on me to get you the head so you can make the piston or something to that effect.
Yes.
If you're going to do this, by all means, man, put the absolute lightest ring you can in it. And this is just for you and the public. I've ran 2 millimeter oil rings before, And I'll tell you, I like this combination right here. I will give up 1 to 2 horsepower over oil control. Now, here's what I mean, because I preach all the time about the oil ring and different things. I got videos on it, how don't let it be such a drag and get bound up. But I will personally prefer a 1 millimeter top, 1 millimeter second, or even less, and a 3 millimeter oil ring.
Mm-hmm.
Because number one, oil in the combustion chamber is going to be a major problem when you're trying to run pump gas. You cannot have oil in that chamber, which we can talk about this more later, but that's going to cause detonation preignition issues big time, especially trying to run that line, the ragged edge of the compression versus the octane rating you have. So oil control is going to be a big deal, keeping it out of the chamber. I also talked to Charlie a couple times about, and just different people about, when you're going to run a pump gas engine and you're pushing the edge where you're, 11 to 1 or 11.5, having any kind of burr or sharp edge in that chamber is critical, that it cannot be there, because the hot spot will always go to the sharp edge. And when you're pushing the fuel like you'll be doing here, that sharp edge could be the thing that kills you. Your thermal efficiency in this engine is going to be awful. No fault of anybody, just the fact that the piston is so large, you don't have consistent heat and temperature across the top of it.
Right.
So I would certainly check in the coatings you can do to help that and keep it more consistent. The smaller the bore, the easier it is to run high compression. The larger the bore, the harder it is on pump gas, I mean. So keep all that in mind. I don't want to start chasing rabbits, but those are some of your things: is ring tension here, oil control, and thermal efficiency is what I would certainly be looking into when you go to get the pistons and rings made.
Yeah. And that's everything. Basically, Race Tech, I talked to them about it. They were recommending, if we do thin on our compression rings, do a beefier oil ring.
They said the same thing. That's wonderful.
Exactly. Good. Yeah. Because the owner wants the thinnest paper thin rings he can get,
Yeah.
Get more power.
And that's fine if it's gas ported. It needs to be gas ported, and the ring face is cut the right way, where you use your cylinder pressure to force them out. That's great. But if they're not cut correctly, if it's a plain Jane square cut ring, you're probably going to have some issues, not today, but weeks down the road.
Right.
And that's why I say getting the proper cut, and it sounds like they're aware of this, so that's good.
Yeah. Yeah, they were on top of that. So what we mentioned Charles for video. I think he did a great job on our heads and intake. The intake looks wonderful, and I'm looking forward to kind of showcasing everything when it all gets here through the process. What do you think of his flow numbers and improvement?
So I got out some stuff that I've done, because we do our own porting and CNC work, and I love Charlie. He's a great guy. So the valve on this head is 2190. Okay. And I got out a set that I did. It was 2180 on the valve, and ours flowed a few more numbers, but again, it's a whole different scenario because we had a slightly different valve angle than these, and we're trying to turn this 8,500 RPM. So it's slightly different. Comparing the two, because I have them pulled up right here. All right. So at 2190 valve size, this is why port shape is so critical. Like you said, Charlie was about 371, and at 2180 valve that I've got here, we're at 378. Okay, and then let's just look at 700 lift, 376 on mine, 371 on his. We're at 378 at 800. Let me clarify that. But he was 371 at 700, and that's really good. And then you look at the 500 number, we're at 348, and I believe he is at 340. So just a couple CFM difference. But his low lifts at 100 and 200 lift are better. Like he's at 75 at 100 and 168 at 200. And we're at 60 and 144. So my head really takes off at about uh, no, but 300 lift, my head starts to do really well. Um, so I say this thing is going to do very well, man. I mean, really. And the cool thing is, he didn't gouge the port to get these. Okay.
Right.
Keeping that throat diameter is so critical because with an engine like this, as much stroke as you have, you're going to be very susceptible to reversion, especially at low RPM. And keeping that port velocity up on this is going to be really important. And I know he done that. We have the heads here. I have them now.
Mm-hmm.
And he just, I mean, it looks great. Done a good job. So yeah, man. The exhaust on the Dodge is typical Dodge, right? Um, we cannot compare one of our small block race heads to a Dodge head. That's just not fair. So the
Right.
Dodge head that he has, I think it flows 241 at 700 or 246 at 800. A lot of airflow. So, and here's the thing about that too. An exhaust port on the flow bench does not tell you the story. So under pressure, hot exhaust, it will not do what it does on the flow bench. It will be better every time. So you can now compensate your camshaft to fix or at least help and aid in any deficiencies in the exhaust. This
Right.
engine is certainly going to need exhaust because it's so much crank to it. So no, dude, I think it's going to be great. It's going to be great. I mean, I can't say anything negative, and I wouldn't anyways. But I mean, honestly, I think it's good, and I think Charlie preserved the port dimensions in a way that will keep your velocity and have good flow at the same time. Because he could have gutted this thing and got, you know, 400 CFM, and I
Right.
promise you, it would not get out of its own way. So I think he done a really good job with what it is, and I'm excited to see it go.
Yeah. For sure. So now that we know our head flow numbers and cubic inches, that back to our camshaft challenge. Where do you start your process? I know uh, we all kind of agreed on we're going to be around 750 lift, and that way our valve spring should be close to cool bind happiness across the
Yeah,
board.
yeah, that's critical for the spring life. And the other thing I told you was, by all means, please put spring rollers on this, um, because the daily drag and drive situation, keeping those springs cool is such a big deal. Such a big deal. Um, I tell the audience, if you take a paper clip and you take and just sit there and bend like this, it's going to get hot and then it's going to break. Well, your valve spring is no different. The valve spring is not paperclip steel, right? But you're still taking steel, that spring steel. It wants to stay in a memory. It has a memory. It wants to be in this position. And now you're forcing it in an opposite direction, and it's wanting to naturally go back to the other direction. So that bending motion will make it hot, and the hot will destroy the spring rate. It just kill it. You destroy the spring rate. Now you've lost your lifter to cam lobe contact. You start losing that, you start bouncing valves and breaking stuff.
Right.
And uh, you'll find that, well, the engine used to pull to 6,500 like a Banshee, but now it kind of feels like it goes flat early. And these are early signs that the springs are done. And you don't want to be putting springs on the engine, every other week. So the spring oilers are such a critical deal. Um, how do I start the cams? A lot of it is, um, gosh, I've been doing this since I was like, I don't know, 14, 15 years old, working with um, just some fantastic people, doing cup stuff at David Penix's place. As a early, he took an interest in me. I went to we started going to church together, and I heard him talk about race cars one day over there, and I was like, what? And then I was just hooked, and he allowed me to come. And so mom would drop me off on the weeknights. I'd be in his shop, and he was a big R&D manager for Exeldine Technologies, who they make all the valve train for Formula One and NASCAR, Spintrons, the whole nine. And I got access to all that through him. And heck, I stayed close to him until probably in the last 10, 12 years. So that's been many years ago. That's been 40 years, 39 years. Good night. Where did time go? So that experience allowed me to understand this. When I change a number on a cam, I expect that number to do a certain thing to the engine. I expect it to make it behave a certain way. And once you learn that, then it becomes experience and dynamic pressures as far as where are they. So we know that this is drag and drive, okay?
Right.
That's got to be taken into consideration. In other words, you can't be throwing the kitchen sink at this thing just for a dyno test.
Mm-hmm.
Number two, longevity, which is part of that. Now we have a limited RPM range. We have a very large crank, as good as head as we could get, and a limited RPM range at 6,500. So we got to have this engine being as efficient as possible at or before 6,500. I don't need it being efficient at 8,000. I need it being efficient down here. So that has to come into consideration, because one would think, well, this is 230 or 538 cubic inches, and heck, we need a cam that's 270, 280 at 50 or 290 at 50, and that might happen. I don't know what these guys are making. So, and it may be awesome. I have a feeling it will be wrong. So you have to take that in consideration. What cam do you put in it? Now, to be fair, if the dyno operator decides to pull the engine to 7,500, that's not fair, because that's not what's being told to the people doing this, right?
Right.
We're told from idle to 6,500, let's get the best cam. So that's where my thought process went into. Not saying it won't turn past 65. Certainly it can and will, but those are the parameters that the owner of the engine set.
Mm-hmm.
With that being said, I'm trying to take absolute advantage of the piston speed that's going to be going on with this, and what I think the cylinder pressures will be, because what I'm trying to do is, number one, help the exhaust create a vacuum to increase scavenging. I don't want any kind of reversion backing up. So if I go way too large, that's a possibility. If I go way too small, my cylinder pressure is going to be through the roof, and the pump gas is not going to work at all.
Right.
So there has to be that balance. This is a tough one, because one of the things you guys did, and I guess this was owner's decision, was you ran a 1/6 rocker arm. The problem with that is the cam core size that you have is so small, because it was stock, that getting the lift at valve to take advantage of the cylinder head that Charlie has worked on so hard is almost impossible to get there with the rock arm ratio versus the cam journal. And what I mean is, I can grind the cam to lift at 800, okay? And the head flows all the way past 800. But the problem is, there will be zero hardness left in the lobe. So I will grind out all of the heat treat of the camshaft just to make it run good on the dyno, knowing that next week that cam lobe will have a trench dug right through the center of it.
The lines right through it, yeah.
Yeah, and I'm not that kind of person, so wouldn't do that to you. So that has to be thought about. In other words, if it was my engine, I would not have chose the 1/6 rocker. I would have went to at least a 1/7 minimum, probably knowing me a 1.75, maybe even a 1.8 on the intake, and got my base circle much larger. And that is longevity and stability for the engine when you do that. You don't take a super fast lobe and put a very high ratio rocker on it. You adjust they're opposite. So if I want to put a very fast high ratio rocker arm on, then I slow my lobe down to compensate. You know what I mean? So
okay,
I can put them both on keel, but that's not going to help you out at all. It'll run great on the dyno, but it's liable to throw a push rod through the rocker arm next week. We don't want that either. So you put a lobe on that works great with a 1/8 or whatever ratio.
Mm-hmm.
So that's the Achilles heel in that whole situation is the shaft diameter and the lack of base circle and heat treat that's available. In other words, so I got to doing some figuring, and I said, okay, if I put this lobe on this shaft, I'm going to have 20 or 30 thousandths, maybe 20 thousandths left on heat treat, and I wasn't willing to do that. I just wasn't willing to do that. Is it mine? If it was mine, would I do it for a race event or dyno competition? Yeah, okay, but it's mine. Is it something I want to do to a customer? No. So there had to be, we had to take that in consideration and say, well, in order for this cam to last and be happy and not break or fail, we're gonna have to back off. And so that's what we did.
Right.
And that is the only thing. Now I would tell you a lot more, but my cam has been done for weeks, as you know.
Right.
And the other two have not made theirs, so I'm not going to help them out.
Gotcha.
So
Yeah.
I don't want to tell any more than that, but yeah, I hope they consider that because it's a problem. And I've been doing cam stuff for decades now, and I know Daniel will know this. So when you and David's going to learn it when he calls anybody to put a lobe on it, they're going to be hopefully they'll remind him, hey, this is this way, and put this lobe on it. You're not going to have any base circle heat treat left, any lobe heat treat left. So this is the issue with that particular engine you've got is we're limited because of the ratio. If the owner would say, hey, okay, I'll put a 17175 on there, I believe you'd see another 20 horsepower on this build all day.
Wow.
Maybe more. Seriously.
That's a lot. I mean,
It's a lot. It could be higher. It could be 25 or more. I mean, I'm actually being lowball here, but it makes that big a difference. I've seen, gosh, man, Joe, I've seen one time I saw a guy get 68 horsepower from a cam change. It wasn't me, but I was there, and it just blew my mind. It blew everybody's mind that low profile changing is about 4 or 5 points of duration, about 20 points in lift, a little bit more lift, about 20,000 more lift. Just a little. I mean, when you look at the numbers on paper, you think, oh, that's not much difference, but that's what that engine wanted. Mm-hmm. And these really big stroke motors are really sensitive, as is really short stroke motors. They are much more sensitive than some of these other engines that are closer together, like a 3.5 crank and a 4-inch bore. Now, I will say, anytime let me put it this way, if the engine is overheaded, like way too much head, or really underheaded, camshaft really impacts it. So, and you're at that level right now where you're borderline too much compression for the pump gas because of your bore is so large. I really think I did this before, 598 big block. It was 10.5 compression, but the bore was ginormous. And I had problems. I had a lot of problems with it. I wound up backing it down to 9.8 and the problems went away. And I had a 271 and 50 cam in it.
Yeah.
On a 112. So 7 something lift, 700 is plenty. It was a lot of camshaft, and we still had detonation issue or spark knock issues. And we had to idle it way down because anything above 950 to 1,000, it would diesel when you shut it off.
Really?
Yeah. Oh, yeah. And a lot of that is because the vacuum was so high. With such a large engine with an inadequate top end that the vacuum was pulling fuel out of the carburetor after you turned it off and it was igniting, which happens a lot if you idle them too high or your throttle blades are open too far on one side of the carburetor. So there's just so many variables that you have to address. But I mean, listen, I'm a realist, and I don't like singing song and dance to people when I know it's BS. I just want this to succeed for you, uh, and the owner. It's not, I compete against the biggest names in the world with Childress and Hendricks and Yates, and we win against them. And so these guys, it's not. I mean, it's just another day in the park for me. I don't care about. Of course, we always want to win, but more importantly to me is that this works for you, and all the effort you're trying to put into it is successful. That really does matter to me. Um,
Yeah.
and I
Well,
think it's potential.
yeah, thank you. I would say at the end of the day, my name's going to be stuck to this thing, and if it scatters in the floor, they'll Mopar Joe. He's a hack. So
Yeah, no, I don't think it's going to do that. But I think there's a lot on the table. That's what I'm trying to say. I
mhm.
think there's horsepower left on the table, and it all starts at the rocker ratio. Um, but also, I don't want you to think that you can't make 750 with the way it is, because I think you can. So again, if you go to the higher rocker ratio, what do I got to do? I got to redesign a whole nother cam. So you're
Right.
talking about thousands of dollars. You know what I mean?
Mhm.
We're not talking about $5 choices here where run this heat range of spark plug versus that one. We ain't talking about that. We're talking about thousands of dollars in the rocker shaft system, thousands of dollars in the cam cores, and then changing push rods because the base circles changed.
Yeah.
These are big major decisions that cost thousands of dollars. Um, yeah, so it's to a point where okay, we could have gotten here, but here we are, and let's make the best of it, and we want it to last 20 years. And so that's where I am at this point, is getting the most power we can, but yet making it last, indefinitely.
Yeah. Well, do you want to add any more to any of the modifications to the chamber, stuff like that that would keep us from detonating? I mean, if it
I mean, deburr. Atomization. I always kick my fuel and air over to the opposite side of the spark. I always kick it to the cylinder wall side.
mhm.
And when you get heads that are already done, sometimes they're directly aimed at the spark plug. And I'm not saying that's a bad thing, but here's the deal: your lean areas is always over in the bottom corner of the intake valve. And it doesn't matter if it's on the right or left side. It always seems to be that this bottom right corner looking at the intake valve. If the intake's on the right, it's also on the left. The bottom right corner is always where the lean area is. So if you, and I wish I'd have grabbed it, man. I've got pistons we took out of engines that the entire surface is completely evenly colored and coated
Mhm.
and exhaust. And I've got pistons that come from other engines that it's just black in this little spot and it's kind of all centered and it's over here. And they don't make the power, and you'll have uneven cylinder wear because all the pressure's on one side of the piston, not the other side, or not evenly across. So getting that fuel and air to be evenly distributed is everything. Now, I find that to be done with port shape, texture of the port, and the valve job. Uh, the chamber being like, for example, if you look at a cylinder head that you buy that's CNC ported, the chamber being CNC ported, that is a polished chamber.
Mhm.
That is a polished chamber. That's what I mean, right? When I say polished, I mean don't grab a cast iron head off a stock engine with all the little casting porosity and roughness to it and put that on the engine at 11.5 and expect it not to spark knot, because it's going to. That roughness, as I showed in that one video, I took a bolt and put a flame to it where the threads will glow, not the center of the bolt, but the threads will glow
Mhm.
because the heat always goes to the sharpest point. So knocking those points down is key. Well, in this head, that was already good to go. There's some spark plug work that Charlie did that needed to be done. And your valve job is, golly, that is the critical area, is having how that valve job lets the air and fuel come outside the valve and then transition to the chamber wall as if the chamber wall is now part of the seat.
Right.
And there's certain angles we use, whether it's 40 or 42 degrees on the top cut, that will cause it to blend right into the chamber, different things like that. Or maybe it's a radius. And I'll tell you something else too. The intake valve, when it's close to the cylinder wall, a lot of guys, and this is just a generic statement, a lot of people want to open that chamber up right there, and you have to be careful with it because that wall on the combustion chamber acts as a venturi for you to when that piston comes down the intake stroke, it allows for a harder pull on the valve. And when you take that wall out really wide, you can lose that suction property from the piston traveling downward.
Okay.
So that's critical. And I know Charlie, I don't think you messed with that, so that's great because I wouldn't have. It looks like you want to do it, but it's wrong. You know what I mean? And then you have to understand my flow bench is steady state and my engine is not. And I did the math on this at 7,000 RPMs. The valve is open 0.0003, or was it 6? No, 0.0007 milliseconds at that RPM range. And for every 1,000 RPM you gain, you drop a whole second less. So from 7 to 8 is now 6. From 8 to 9 is now 5. And we're talking milliseconds, 3 zeros and then the number. Now, you think about that. I don't even know if we don't even blink that fast.
Right.
That valve is open and closed in that amount of time. So when you just gouge the combustion chamber open, thinking on the flow bench, it's flowing like crazy, you've lost your pull on the piston downstroke because it's only open. I can't snap that fast.
Right.
So that, of course, that's why turbo and superchargers are such a big deal, because at that RPM, it's there. It's under pressure. But when it's naturally aspirated, this head work becomes more critical than ever. So those are things that making sure it's not lean, making sure it gets the right fuel and air will help prevent detonation of Spartan Hawk. So, and yeah, I mean, there's a mile we could go into that, but like I said, right now I see everything is going as the best it can be, and I mean, right now it's only looking positive to me. So
awesome. That's good news that we need. So
yeah.
Anything for success on this deal. I wanted to skip to this one. Does this engine combination feel more challenging than like a LS build or like a small block Chevrolet?
Only in the fact that we are limited with the rock arm ratio. I keep coming back to that.
Right.
Because you don't want to grind off the hardness of the camshaft. That's the deal with me. Other than that, no, it's the same. I mean, heck, I just did a 383 a couple months ago, and we were seeing what we could make with a 9-to-1 motor. So I think it pumped 9.3 and a 218 at 50 can. We made 503 horse or something like that. And so, no, it's the potential is there. And it was just a regular 383, 30 over stock crank. In fact, it was the stock crank and rods. And the piston compression height was a stock. I did gas port the rings, and I did do the, gosh, I say it all the time. I did knock the edges off the high spots of the homes. What am I talking about? Platooning.
Oh, yeah. I saw your video on that.
Yeah. Oh, I got a much better thing now because we use carbide brushes in the machine. All right. So I was trying to find something for the person at home to do, and I have got the ultimate tool for them. I just tested it a couple of days ago, and it's way better than the Wiseco brush, and it comes in gigantic bores for people. So I forgot the name of it, but I'm going to show it in the video. And it's 800 grit, about 10, 15 strokes, man. It's so good. I'm going to show it to everybody so they can look forward to that.
Okay.
But it's even better than the Wiseco. But anyway, those were the things I did. We rolled the deck. The chamber was bigger than the bore, so we corrected all that. Yeah, just look at every single detail. And if it says in your mind, well, that's only going to give me 1 to 3 horsepower. Okay, But after 10 times, that's 30 horsepower. If that cam is a little sticky, fix it. Find out what's causing it. If the crank has got a little tight spot, fix it, because all that adds up to power. And you may have ridiculous time in this thing, but by the time you're done, no one could have made the power you made at that compression ratio with that head, with that cam, that day. You might have had the strongest 383 Dodge in the world because no one's ever done that. And you did it by beating every little nuance problem that arose rather than just let it go.
Yeah. I end up with those problems every single build. There's not like an easy build. There's nothing easy anymore.
Yeah. Do you remember the I'll tell you, push rod length, right? Getting the center of the rock arm and center of the valve and the push rod length being high up in there as it can be, that's cam duration and lift. And I'll tell you, it's even more evident on the overhead valve 4-cylinders that run followers. Those things are set by the valve installed height, right? So the tip of the valve, the valve is ground, seat's ground, you stick the valve up in the head, and then the follower the cam's on top and the follower rides a cam lobe. So the cam pushes down on the follower and the follower pushes down directly on the valve. You can change that installed valve stem height and completely change the lift of that of the cam. Not mechanically, not grind wise. It may be supposed to lift the valve at 560, and you can make the valve stem longer so that the follower is now higher up on it, and it will lift at 580. Or you can cut it too short, and now you're only lifting at 520, and the whole time you're thinking you're at 560 at this duration, and you're not even close.
Right.
And the thing runs okay, and it looks okay, and it's not breaking, and you are leaving 20 horsepower on the table because your valve geometry is wrong. And these are things that you are going to have to deal with because it's not going to tell you. It's going to run good, it's going to crank, it's not going to break. But because you missed this by 15 thou, you left 20 horsepower on the table. And that's the reality of it. So that attention to detail is going to be huge.
Yes, sir. Well, my other question, what do you propose our best case scenario is for horsepower and torque? If we're just talking peaks.
Are you going to test it on 93 or something better?
Probably 93. Normally I buy 5 gallons on the way to the dyno and try to hit a shell or something that really has 93.
Yeah, I know, right?
And I pump 10 gallons into my truck before I fill the jug up just in case there's some in the hose. You know what I mean?
Yeah. It's sitting there a while.
Because if he really wants to drag and drive it, I like to find, and I've had people come from out of state or whatever. I said, bring the gas that is at your local gas station that you're going to be buying every week. And they show up with 10 gallons. It's
so true, Joe. And I'll tell you this, look at how many, especially now, right now, what's going on in the world, which we can talk about that. Good night. I don't understand some of this, but people don't buy 93 octane.
Right.
They buy 87. So how long is that 93 set in that tank in the ground? How stale is it? And you're thinking, I got a fresh can of 93 and it's been sitting there 6 months. And we found, we did a test with just 110 VP, and we were testing on this. The drum we had was 2 months old. It had been open 2 months and had our pickup tube in it for the dyno cell. We were running on about a couple months, and we ran out. So my buddy goes in the back room, grabs the other 55-gallon drum, fresh seal, pops it off, puts the pickup in there, and that thing picked up 20 plus horsepower.
Wow.
That's all we did. And the key is the fuel loses its octane the moment you open the seal. 100% fact. So when they pump this from the truck, or it comes out of the manufacturer or whatever they make it, goes into these tanker trucks, they drive to the local place, they pump it in the ground. It's now exposed to all kinds of humidity, hot and cold. The tanks are not airtight because the fumes will explode, so they do vent.
Mm-hmm.
So they are losing octane as it sits there. That's my only fear is, and this is with any engine, not just this, is when I build it to the ragged edge of 93, like you just said, is it really 93 now?
Right.
Because there are levels. There are levels to fuel, and you can buy unleaded pump gas from VP or from Sunoco or whoever that is high quality, consistent, and you'll get by with it no problems. But to go to a mom and pop that hadn't sold 93 in 6 months, it could destroy your engine because it's no longer 93. So these are things a guy has to consider.
I was going to say to add to that, we did a dyno 512 and the guy was using E85, and I went ahead and bought 5 gallons of E85, and we the E85 at Kuntz and did back to back, and it was like 12 or 15 horsepower difference.
Right. So what do you think caused that? The staleness?
I'm sure, it actually being E85 in that jug versus whatever. Yep. I don't have one of the test kits like Andy Wood showed in a video.
Yeah.
Mixing, and you could see the difference. But because that's what the man was going to buy. He said, I want to run pump gas E85, and it was 12.5 to 1 or something compression. But sure enough, we poured it in, and it looked so much better.
And there you go. Now, this engine was much more than that. It was an all-out race motor, so it was way more sensitive. But and I think the 110 unleaded gas is more sensitive than E85 is, just because E85 is 85% alcohol. But with gasoline, it's not. And if it goes bad, it's really awful. But these are things the modern day hot rodder has to deal with. And I've gotten to where, if I can, I'd rather build an engine between 9 and 10 to 1 and make the power other ways. Leave the compression at home. Mm-hmm. And that way, no matter where he goes, he can cut it off and it shuts off. It ain't hard to start. It doesn't detonate, doesn't pre-ignition. We're making power with parasitic drag reduction, the right head and intake combo, and the right camshaft, and leaving the compression at home. And it has served us very well because if you add compression to that combo, you really got something. So it's a lot more work. It's harder to do. And quite frankly, it may even cost a little bit more. But longevity-wise, by keeping the compression way down, I mean, you just don't have anything to worry about. So, but man, it's no fun. I mean, there's nothing funner than stepping on the throttle with big compression and big cubic inches. I mean, there's just nothing funner than that.
Mm-hmm.
It blow the tires off no matter where you are on the street. You know what I mean?
Right. But I mean, as far as like a number on this thing, I would like to at least see 700 both ways. I mean,
I think you're going to see 700 both ways. I think you will see 700 both ways. I mean, here's my estimation. I'll just tell you, I think I'm estimating about 750 horse and about 720 on the torque. And I know that sounds backwards, but that's because that's how I design my cam.
Well, I know like the guys at Kuntz, they do big block Chevys and Fords all the time. And they were so pleased with like the Mopar strokers I bring in. They're like, man, it's making 700 foot-pounds for, a 2,500 RPM range.
Yeah, for days.
Forever. And it's like those same 270 heads on one engine. And he said, man, you can tell like it finally noses over 6,500 or something. It's done. There's no more left in that.
Yeah.
But now this combination's a, 36 more or 26 more cubic inch and a little less compression. So
yeah,
I don't know.
And it's a different, at least for me, it was a different drive in that it's going to be a daily or not daily, drag and drive type of car. And when I think drag and drive, because I do a lot of those, I mean, the guy's been driving 1,000 miles.
That's what he wants.
A to point B. And so that to me is a different approach than just getting all I can out of an engine. Now, if the guy says, hey, I want all I can, of course, all right, sure. But I did look at that and take it into consideration. And I have seen I've watched some of the videos you've done on the big strokers, and I mean, yeah, that one in particular, I think I don't remember if I think it was I don't remember the cubic inch, but it was like 800 plus torque.
Yeah, that was a 580. Yeah, and it was 800 plus torque and like 912 horsepower.
Yeah, wow. I mean, it was impressive, and I was like, yeah, that's nuts, man.
We were excited for that for sure.
Yeah, we have a crate engine that makes that, and it was 10.8. I've backed it down, so I need to retest it and see where we are with it. But I kept having it. Just there's so much surface area on the piston trying to run pump gas 93. It's just a little scary. So we backed it down some. I think it makes somewhere around 880. And it's a hydraulic roller, a big one, but it's hydraulic roller. 598 cubic inch. So nice, good stuff. I think you'll see. I hope you see 750, and I think you'll see maybe 720 or more on the torque side. I'll tell you, it's hard to know because the intake manifold on this particular rating is so critical. 25 years ago, even a little further back, I did not realize how much an intake manifold mattered until, like I said, probably when I was about 20 years old. I started seeing we were taking cup engines and putting a maximum ported Victor intake on it, and it just sucked. And we would go to sheet metal intakes and pick up 100 horsepower.
Wow.
Unbelievable, man. And that's where you are with this because it is such a large engine. It's going to want all the airflow it can get. Mm-hmm. And I know Charlie did the best he could. No one's saying anybody could have done better, but we're saying these are just the part restraints, you know. So right. I just don't know. It's just so hard to guess. But I think you'll see 750. I really do. I hope you do.
I think we all agree when it goes in the car, it's probably going to break something. I mean,
something's going to twist.
Yeah, if you dump that clutch, in first gear at $4,000, even it's going to snap something. So
yeah, I'll listen.
Looking forward to that, I guess.
I'll say this: I'm going to stick to my guns. I think if we see 750 horse and we see between 715 and 725 torque, I think you should be happy. I do.
Okay.
Now, if you decide to throw 110 at it just to see what it does, that'd be interesting.
Yeah.
That'd be interesting. I would love to see you do that and then just, turn the timing down to 93 and see what it does both ways. But of course, you guys doing 3 cams or however many you're going to do, it's a lot of work, as you know, and you'll be busy.
And it's going to be hard. It would be hard to test a 110 and 93 on every cam. You know what I mean?
Maybe whichever cam done the most power or torque that you liked, just to see how the motor responded differently on the compression. That would be kind of interesting just for my benefit. I'd like to see that. But because every piston and combustion chamber responds differently. We've seen LS motors want to be at 29 degrees of timing no matter what you did. It didn't change anything. And that's all in the chamber shape. So it'd be some neat information to see how well and efficient this chamber is to sensitivity of octane.
Yeah.
Because there's other things that are in the gas. There's anti-detonation stuff. There's other mixtures in racing fuel that is not in pump gas. So, we have to keep that in mind too.
Yeah. Well, I know we're pushing up on our hour here. I guess the big question is how does it feel? You're going up against DV and Daniel, like they're camshaft men, like
I've been at it longer than Daniel, quite a bit longer than Daniel. And David, he's been at it next to the good Lord. No one's been at it longer than David.
Yeah.
Daniel grinds camshafts, and I mean, talented guy, and I've been designing cams for well over 30 years. So um, we race against the best in the business and win. In fact, we just won a big race in Mexico last Saturday. I, hey, it's just another day at the office. So
Right.
we just want to see everybody be successful. We don't. Good luck to them.
It's a good friendly competition. I'm glad to be
Yeah,
involved.
man, exactly.
Yes, sir.
Exactly. And here's the thing: Daniel's out there trying to make a living and feed his family. Uh, me too, to a certain degree. Um, I have other things, but David, David's semi-retired or retired. I don't know. David's been around a long time. But I would never want to do anything to take money or anything out of a man's pocket who's working hard to feed his family. I will tell them this: if they're not on their game, they need to stay home.
Right.
And I mean that in the nicest way.
That sounds fair.
That's
For
what
sure.
you want to hear. I just said it. but I wish them the best.
Oh yeah.
But yeah, they're not going to win. I'm
There
picking
you
anyway.
go.
No, we're this is what we do, man. So yeah, it's no big deal.
That's great. Well, if you got anything else you want to share, I'm tickled, man. You answered everything I could imagine.
No, I do want to say thank you for talking to me. And I had some things happen to our family and some terrible things. And people were so kind. And I want to say thank you to those who kept us in their prayers and that kind of stuff. We did lose a grandchild, and it's been rough. Last 2 weeks have been very rough. And I'm also stupid, really busy, and it's just at the end of the day, all you have is your family and the good Lord, and you just try to keep trucking on. So he's in the child is in a much better place, and we're just trying to get through and um, keep at it, keep going. So, but there have been some very kind messages and comments. I know there's some people out there that genuinely care. I just want to say thank you very much for that.
Yes, sir. Well, I'm gonna put a link below if they're not already checked you out, man. There's a bunch of stuff they can learn and watch. I like
I'm
search
trying to
back
get back
on old
to
stuff.
it. I have a lot of stuff I want to talk about. I just have not had time to stop long enough and make a video, and kind of under the gun right now because I got some motors that has to go out. But I will start making videos again very soon, probably in the next few days, I hope. But I enjoy your channel. I love your intro. I told you that.
Right.
Do this thing for me. Welcome back, Mopar fans, or whatever you say there.
It's all right, Mopar people. Welcome back to the channel. I'm just Mopar Joe.
Yeah, I love it, man. I love it. It's catchy.
I gotta do it really fast sometimes because I'll get off topic.
Yeah. I'm very competitive at the end of the day, but I'm also, I wish people the best. So that's how it is. But yeah, don't come. I mean, don't think you're gonna beat Salter Racing because I don't think so.
Right.
I'm gonna pile it on deep. So I
Good.
can't wait to hear their responses. But I would help those guys out in a heartbeat if they ever need anything. But yeah, we're the best. So that's just it. Who's number 2? That's the next question.
There you go.
No,
right.
we screw up with the best of them, there, Joe. We screw up with the best of them.
Yeah. Oh man, that's my favorite way of learning, or the only way I learn, I guess. But I'm going to post this video as as a video instead of a live between us because there's no way I could have kept up with all the comments and stuff. So there'll be a million questions under this, and I'll do it as a premiere where people can comment. All right, Mopar people.